All right, so here's another problem, and this one involves two formulas this time. So the volume of a sphere is increasing at a rate of 4 meters cubed per second. I'm going to stop and draw a sphere. Okay, there's my drawing of a sphere. Find how fast, that's a rate, ddt, the surface area, I'm going to call that SA, dSA, when the diameter is 28 meters. Ah, look what I did there. Here's another good habit. I don't like diameters. I'm just going to come out and say it. There, I feel better. I don't like diameters. I prefer the radius because radius tends to appear in more formulas than diameter does. And even when you have like pi d, cherry pie is delicious, I use 2 pi r for circumference anyway. Okay, so sorry diameter fans, but I like radius. Let's relate the quantities, right? How do I relate surface area to volume? I don't know off the top of my head a formula that does relate volume to surface area, so I'm going to use both of those, and they're going to help each other out. 4/3 pi r cubed. That's a good one to know. Sometimes they give it to you, but I would know that one. What's the surface area? 4 pi r squared. That's another kind of useful one to know, all right? So I am going to, since I was given dV dt, I'm going to do volume first, all right? So let me move surface area out of the way. So let's take the derivative of both sides. We're going to relate the rates. So what's the derivative of v? V prime, you might say, or dV dt, all right? Now, what's the derivative of 4/3 pi r cubed? Now, r is the only variable here. Oh, by the way, no constants, right? The entire sphere is growing, so nothing's remaining constant here. But this 4/3 pi, that is a constant multiple. It's a coefficient. So that just comes down into my answer when I'm taking the derivative. 4/3 pi. Don't forget that pi is a constant. And now the derivative of something cubed, r cubed, think of r as like a function. Derivative of something cubed is 3 times something squared times the derivative of the inner, the derivative of the function, which is dr dt. All right, so this is the derivative of volume. Now, let me plug in whatever I can. R is 14 at this instant, right? So here's 14 over here. So 4/3 pi times 3. Oh, the 3's actually cancel. So this is really 4 pi times 14 squared times dr dt. Do I know dV dt? Oh, dV dt is 4. So why don't I solve this for dr dt since that's the only thing that's there? Divide both sides by 4 pi 14 squared. Can you see this? I think you can. Sorry, it's crooked. The 4's cancel. 14 squared. Give me a second. Let me figure that out. Haha, it's 196. Okay, so I was able to find dr dt. It's 1 over 196, 14 squared, times pi. Make sure the pi's in the denominator. Meters per second. Radius is a linear, one-dimensional quantity, right? So it's just meters per second. Now let's go back to surface area, because we didn't find dSA dt yet. Down here is surface area. I'm going to move it up here. So let's do the derivative of this. The derivative of SA is dSA dt. The derivative of 4 pi, the 4 pi, again, is a constant coefficient. Just bring that down into your answer. The derivative of r squared, derivative of something squared, is 2 times something to the first. So it's going to be 2r to the first times the derivative of the inner function, dr dt. Now let's plug in what we know and find what we don't. 4 times 2 is 8 pi. I'm going to write a blank space, as Taylor Swift would say, and I'm going to fill these in. Do I know r? Wasn't r 14? And dr dt I just found was 1 over 196 pi. And I could actually leave it like this as soon as I put units, meters squared per second, right? Square meters is area, volume is cubic meters. But I'm going to simplify a little bit. I know 14 goes into 196 14 times, because it was 14 times 14. 8 over 14 I could reduce by cutting it in half. I could make it 4 over 7. So I think my final answer is going to be 4 pi over 7. Oh, wait. Over 7 pi. The pi's cancel. 4 over 7 meters squared per second. Check it out. This is problem 4 from 2019, and it's a great problem to practice because it not only starts out with a related rates problem, but it also asks us about function analysis and solving a differential equation. So this is a great problem to do. Let's go over it together. So find the rate of change of the volume in the water, volume of the water in the barrel with respect to time. So they want us to find dV dt. So I'm going to do what I usually do, which is when I map out the problem, find dV dt when The height of the water is 4 feet. Okay, so if you read the question like I did, the water is draining out of the bottom. So the height is a variable that's decreasing. So dHdt is going to be negative. And in fact, here it is. Myth confirmed. They give us a formula for dHdt. Look at this. A diameter, my arch nemesis, right? The diameter is 2 feet, which means the radius is 1 foot. And that is a constant. So when I set up my equation, I'm going to plug 1 right away for radius. Okay, so now let's relate the quantities. We've got volume, height, radius. Volume of a cylinder is pi r squared h. They gave it to us. See what I did there? I didn't write pi r squared h. I wrote pi 1 squared h. This cylinder is not getting wider or narrower as the problem goes on. The radius of the water itself is remaining 1. Okay, so I really have pi h. That's going to be great to differentiate. Great to differentiate. That's my next album coming out. All right, so let's differentiate v, and I get dv dt. And what's the derivative of pi? Remember, pi is just a number. Bring that down. Pi h. The derivative of h is dh dt. Okay, and dh dt I happen to know here. So this is really pi times negative 1/10, which gives me that, times radical h. And now since I did the derivative, since I have the related rates, I can now plug in this instant for h. Radical 4, that's 2. So I'm going to have negative 2/10, which is negative 1/5. So negative pi over 5 is dv dt. And if I do some dimensional analysis here, rate of change of volume is going to be cubic units. Let's see, where are the units? Feet. So it's going to be cubic feet. And since it's a rate, it's going to be per unit of time. Where's the unit of time? Seconds. So feet cubed per second. Great. Let's take a look at part B. When the height of the water, so this is an instant. The height is not always equal to 3, but when it is the rate of change of the height, this is mapping out the problem, by the way, so I don't have to read it 100 times. Is the rate of change of the height, dHdt, increasing or decreasing? How do you tell if a function increases or decreases? You look at its derivative. So I have to look at the derivative of dHdt, the derivative of the derivative, the second derivative. So is ddt of dHdt, this is like h double prime, or the way we write it is d squared h over dt squared, which seems bizarre, but that we're not actually squaring anything. We're taking the derivative of the derivative with respect to t twice. So the second derivative of h with respect to t twice. That's how I read that. And we want to find out if that is positive or negative, because if the derivative of dHdt is positive, then dHdt is increasing. So dHdt becomes like our f of x. And this is our f prime of x, right? That's how you analyze a function. Okay, so we need to find d squared h of dt squared, the second derivative. So we need to take the derivative of this equation here. The second derivative of h with respect to time twice is going to be, well, negative 1/10 is a constant, so that comes into my answer. The derivative of radical h, think of radical h as h to the 1/2 power. The derivative of h to the 1/2 is going to be 1/2 h to the negative 1/2. And because h is a function of time, I need to multiply by dHdt. That's the chain rule. All right, great. So this is kind of complicated looking, but that's okay. Now I'm going to plug in 3. Since I just did the calculus part, now I'm at liberty to plug in any instantaneous information. So plug in 3 for h. 3 to the negative 1/2. What's that? 1 over radical 3. So this is going to be negative 1/20 radical 3 times. Don't I know dHdt also? Oh, well, here's dHdt. If I plug 3 in here, I get radical 3 over 10, and it's negative. So negative radical 3 over 10. Oh, and this is perfect. I just love me some canceling. Radical 3 cancels radical 3. Negative times a negative is positive. 20 times 10 is 200, so I get positive 1 over 200. And because that's a positive number, dHdt is increasing when h equals 3. So I'm just going to write that out here. Since d squared h over dt squared is positive 1 over 200. Let's use some units here. This is feet per second squared, since it's acceleration of a linear quantity. So since we have a positive second derivative, dh dt is increasing. All right, on to part C. So part C says, at time t equals 0, the height of the water is 5 feet. So that's the initial height. H of 0 equals 5 feet. I'm going to write that down. Use separation of variables. That means solving a differential equation by cross-multiplying to separate the dHs and the dTs, or the dYs and the dXs, to find an expression for h in terms of t. So they want me to solve for h in terms of t. So don't just solve this for h, because then it's in terms of dh and dt. They want it in terms of t. So I'm going to take this differential equation, which is just an equation that's defined in terms of a derivative. I call them diff EQs. And I'm going to cross multiply this, all right? So I'm going to multiply the dt over to here. So here's what I would get. When I separate the variables, I get dh equals negative 1/10 radical h, I'll leave it as h to the 1/2, times dt. Now, I need to move this part to the other side. I need to get the h with the dh. So I'm going to divide by h to the 1/2. So this is going to be 1 over h to the 1/2, or h to the negative 1/2, if you follow my algebra there. Cancel it out there. The negative 1/10, that could be on either side. It doesn't matter. And now that I have the h with the dh, and there are no t's, but I have negative 1/10 with the dt, I'm going to integrate both sides. The integral of h to the negative 1/2, I'm going to use the power rule for integrals. It's going to be h to the add 1. Negative 1/2 plus 1 is positive 1/2, and then divide by that number. But don't divide by 1/2, multiply by the reciprocal. That's what division really is. There's no such thing as division, folks. So instead of dividing by 1/2, I'm going to multiply by 2. It's the same thing, and it's plus a constant. I'm going to call it C1. That equals the integral of negative 1/10 dt is negative 1/10 t, plus another constant, C2. And now let's use some more algebra. Most of calculus is algebra anyway. All right, I think it's time for a color change. So I have 2h to the 1/2, or I could write this as radical h if you want the whole time. That equals negative 1/10 t plus, I'm going to call it C3, and now I just have to get h by itself. So I'm going to divide every term by 2. Guess what C3 over 2 is? C4, a constant divided by 2. So I have h to the 1/2. Maybe I'll write radical h because I'm going to square it in a second. Negative 1/10 over 2 is negative 1/20 t plus a constant. And now I'm going to square. All right, maybe I'll go over here. So h equals negative 1/20 t plus a constant. This is a t, by the way. My t's look like pluses. Squared. Great, that's called my general solution. Don't stop there, though. I got to find out what the plus c is, and they gave me an initial condition. Here it was, and here it is, and here it will remain. H of 0 is 5. So I am going to plug in 0 for t and set it equal to 5. So the height is 5. T is going to be 0. So I get c squared equals 5. So I guess that means c equals radical 5. Great. That's also not my answer. Don't stop there. Don't stop me now, as Queen says. H equals negative 1/20. All right, here's my chance to redeem myself. Let's make a nice fancy t. There we go. Plus radical 5, the quantity squared. Yay! This is an equation for h, an equation of h, an expression for h in terms of t. So that would be my answer for part C. This was a great problem. I hope you had a lot of fun. If you liked this video and you want to see more, then please subscribe to my channel. It's the best thing you can do. May the math be with you.